I don't know how much of algebra you guys got through in elementary school. Maybe you didn't. But with algebra, you have different parts to it. So we have something called a variable, something called a coefficient. We have something called an algebraic expression, where you can express a scenario in terms of algebra. We also have something called a term, a constant term, and a variable term. So we'll go through each one of them one by one. So the first one is being a variable. So a variable is a letter used to represent a quantity whose value can change. So we can have x, y, a, z. We can literally have also the whole letters of the alphabet. They can all be considered variables as well. The reason being is because I can assign any of these variables to a value. So for example, what do you guys want x to be? Let's see. Give me an integer for x or a number for x. Maya? 4. X can be 4. So this is saying that if I have an algebraic expression with x, wherever I see x, I'm going to plug in the number 4. Someone give me a value for, let's say, y, Ethan.
Maybe 3.
3? Okay. They can also be fractions as well. So someone assign a value to a. John? 3/4.
I think Keegan said 7.
I saw that. He was just too slow and I read it too slow. And they can also be decimals. Kareem? 0.5. Okay. So this is basically me saying that wherever I see these variables, I'm going to plug in those specific values. So an example would be, let's say I have just x. So let's say I have x plus y.
That means 4 plus 3.
Yeah, exactly. Thank you, Ethan. That means 4 plus 3. So wherever I see x, I assigned it to be 4. And wherever I see y, I'm going to plug in the number 3. So I'm basically saying 4 plus 3 gives me 7. So that expression would give me an evaluation of 7.
Which is what you wanted to put the number as.
Mm-hmm.
Yeah, that's what I wrote down. 7.
And the only reason it gave me 7 is because I assigned x to be 4 and y to be 3.
They're pretending to be numbers.
Yeah, I can make x 5,440 if I wanted to.
Whoa. 900.
Yeah. So you're saying if I have something like, yeah. So yeah, Kareem, that's exactly what that means. So another example is we have a number attached to the variable, which we're going to learn about in 2 seconds. So that number in front of that variable is called a coefficient because it always stays the same. 4 is always going to be 4. It is never going to be anything else. So in this case, because my x has a value of 3, I need to plug in 3 for x. Sorry, 4. X has a value of 4. So it'd be 4 times 4 plus 3. Okay? Matthew?
Question.
Yeah.
Why would you put 4? No, we'll take it to 4. It doesn't make sense.
Pardon?
Wouldn't it be like 4 and then 4 or x and then another x? 4 and 4. 4x. And that already goes 4.
Yeah, 4x is just 4 individual x's being added together. So this expression would give me 19. And like Kareem said, that is something called a coefficient, which is the number by which the variable is multiplied by. So for example, in this case, Kareem picked 4x, which means my variable x, or whatever x is assigned as a number, will always be multiplied by 4. So this guy is never going to change. Okay, that will never change because -4 will be -4 in that case. 4 is 4. If it's multiplied by 3, if we have 3x, 3 is always going to be 3.
After listening to you guys' questions.
Any questions so far about algebra? No? We're good? Yeah, I'm going to keep that up there. I'm going to zoom in a bit because sometimes, stuff can be small. So again, I'm going to repeat for probably the 5th time. If you need extra help, just come find me at lunch or even tell me to stay 5 minutes after school. I'll give you extra help. Okay, don't be shy to ask me for help at all. I'm already staying after school anyways because of basketball, so there's really no point for me to go home fast, so you guys can ask me questions after school. And also, I'm coaching soccer, so during soccer season, you guys can ask me to stay behind and ask me for help. Okay. Now, the next thing we have is called an algebraic expression. So this is a mathematical phrase made up of numbers and variables. So for example, we can have 2x minus 3y. That is considered to be an algebraic expression. So in order for me to evaluate that, I would need to figure out what my x is assigned, what number x has assigned, and what number y is assigned to as well. So in the above, we already had x is equal to 4 and y is equal to 3. So if I asked you all to evaluate 2x minus 3y, what would my answer be? Let's see. Matthew?
8 minus 9.
Okay, which gives me?
-1.
Yeah. And that gives me -1. Okay. However, if we set my expression equal to a specific value, that is then called an algebraic equation, meaning that there's only one possible value that x can be in order for my equation to be true. So this case, x cannot be any number. It has to be 1 because we have this guy over here. So just using, I guess, logic, what is the only value x can be for my equation to be true? There's 1. There's 1. Gian? -1. So in this case, the only way my equation is true is if x is equal to -1, and we will check that. I'll show you guys how to do it algebraically later on. But let's see if I assign x to be -1 if my equation is true. So I have 3x plus 5 is equal to 2. So Gian said x has to be -1, so let's try that out. So wherever I see x, I'm going to plug in the number -1. So I get 3 times -1 plus 5 is equal to 2. So all I'm doing is checking to see if this left side of my algebraic equation is the same thing as my right side. So what's 3 times -1?
-3.
Yep, -3 plus 5 is equal to 2. I get 2 is equal to 2, which means that Gion's x value was right. So the only x value that makes my algebraic equation true is when x is assigned the value of -1.
Makes sense.
Totally makes sense.
Okay, some of you guys might find algebra actually very easy. So
Really?
I don't find it very easy. I find it like challenging. So I can look more. Not challenging.
Some people may find it challenging.
I don't know. Some people may find it easy.
I find it easy. I find it.
Some people may find it challenging.
I know. Okay. So I'm going to give you a couple more seconds to copy, and then I'll move on. Yeah. Okay, guys. Sean's asking a question. Need to hear.
If the equation like always starts like it equals another number, would that number just follow until the end and that would always be the answer?
Yep. Because I'm trying to figure out that if my left side gives me the same number as the right side gives me.
Okay.
That makes sense.
Wait, so if it just, so say, like I did something wrong, it's just like in the equation,
Mhm.
and it didn't equals 2.
You'd have to figure out a different value.
Oh, okay.
All right. So the next thing we have is called a term. So a term is a number or a variable or a number and a variable combined together. So an example, a term is 6, one term is x, another term is x squared, another term is negative 5y, and another term is a over 2. Do any of those things have anything in common? No, which is why they're all individual terms and they're all different. What you guys are going to notice is that even if we have, let's say, 2 times a squared b times c, is that one term or 3 terms? Someone said it. I heard it. Danica? It's one term. This is one term. When we talk about a term, there has to be an addition or subtraction splitting that identifies that we're going on to the next term. So, for example, we're going to get that to, I think, closer to the end. So, in order for us to determine when a term starts and ends, it's determined on if it's being added or subtracted by something. So, this is one term because there's nothing being added to it after. However, if I had 2a squared plus b minus c, how many terms would that have? Maya? 3. So again, terms are separated by addition and subtraction. Okay? Which means that I have 2a squared as one term, b as another term, and c is my third term. So now we have something called a constant term, which is a term that has no variables. So there's no variable attached to it, and the value does not change. Obviously, it's called constant because when you have a numerical value, you can never change the value of that number. And last but not least, we have something called a variable term, where it's a term that contains both contains a variable and a constant. Its value changes when the value of the variable changes. So like I said, something as 2ab, it has a constant and a term, but it has a constant and 2 variables, but when they're combined together, it's all one term. Okay, same with 5x cubed. It has a coefficient and a variable, but when they're combined together, that means one term. When a constant and a term are together, it's basically another way of saying multiplication.
Two times a times b.
Mm-hmm. Any questions, thoughts, concerns, worries? Yep.
Do you mind zooming in for a bit?
So when do the test things where like ask questions?
What would 8 more than a number be as an algebraic expression? Maya?
8 plus n.
Yeah. So she's making this n. It can be 8 plus n. Or if you guys really wanted to, n plus 8 also works. Doesn't really matter because with addition, it'll still give you the same answer. Okay, so now I have something that's 10 times greater than a number. What would my algebraic expression be? 10 times greater than a number.
The number times 10.
Yep, the number times 10.
Should be like x times.
Yep, so we're going to have either 10n, and that's how we're going to write it. Okay, usually it's the coefficient first, and then it's my variable. So we're not going to write 10 times n, we're just going to write 10n. And then the last one,
What's 10 n?
so if we have half of a number, what would my algebraic expression be? Yep.
Maybe fractions too. So 1/2 n.
Yep. So you can have it like this. Why do you sound so surprised that you got it right? We have 1/2 n, or you can also write n over 2.
Wait, there's still some. Alex one.
Okay. Any questions about this so far? Pretty straightforward, I hope.
Oh, yeah. Like you do n over 50. Or
No, it says half a number.
Half of a number. So it's n over 2 or 1 over 2 times the number.
Or if it says 15 times.
If it's 15 times greater, then it'd be 15n.
Yeah. Now you get it, Matthew?
I get it.
So I'm going to move down. So now we have, when we combine an algebraic expression with a bunch of terms, they can be considered different types of polynomials. So a polynomial is an algebraic expression consisting of one or more terms connected by addition or subtraction. Okay? So obviously here we have 3x plus 2y. How many terms does that have? 3x plus 2y. How many terms, Kareem? Yep. 2 terms. 5a squared minus 3a plus 10. How many terms does that have? Yazin? Nope.
3.
3.
You forgot there is plus 10.
Yeah. And a squared and a, they're not the same thing. They're not the same thing. So the first polynomial we have is called a monomial, which is a polynomial that only contains one term. So for example, that can be 5x, 7y squared, 50, just x, 25y, 14y, doesn't matter. It's just one term by itself. Okay, there's nothing that comes after it. A binomial, just like bilingual, it's a polynomial that contains two unlike terms. So the terms have to be different, okay? So we have 5ab squared and 5ab. Those are two different ones, okay? 2x plus 3, again, two different terms. 5n squared minus 7n, again, two different terms. Now let's see if you guys can tell me how many terms this guy has. We have 2x plus 7 minus x. Pardon? Kareem? Nope. Sean?
Is it 1?
Nope. Matthew?
2.
Why?
Oh, why? It's like the example, 3x plus 2y.
Okay. Maya?
Because X is there twice.
So 2x and this negative x have something in common. What's their commonness, if that's a word?
They're both x.
They both have x's, right?
The same value.
So x is the same variable. The only thing different is the coefficient in front of it. Okay. So if I were to simplify this, I can also rewrite it as 2x minus x plus 7. And think of this as regular addition and subtraction, okay? Because they have x as the like term, I cannot subtract. I can't say x minus x. I can't say the x terms by itself can cancel each other out. We're just looking at the numbers in front of the x's. So we have 2 and a 1. What's 2 minus 1?
-1.
2 minus 1.
Oh.
Just 1. So I get plus 1x plus 7, and that would be 2 terms. Okay? So this is what we're going to learn a bit later on, I think, in 2 lessons. But if there's no number in front of a variable, that number is always assumed to be 1. Okay? Yes, Kareem?
Sorry, on a test, can you tell us what X would, like, what it would be affected?
Yeah, I would be like evaluate if x is 4. Yeah, Yazim?
So just to make sure, so like in the variable, there's no number beside it, so just 1.
If there's a variable with no number beside it, it's always 1. Which is why we never write 1 and x, we just write x. So these guys right here, so I'm going to write it out. This is language that we're going to learn in a couple of days. These things, 2x and negative x, are called like terms.
Like
Yeah, because what do they have similar, Ethan?
x.
Yeah, that's why they're called like terms.
Okay.
And then the last type of polynomial with 3 is called a trinomial, because tri means 3, triangles 3 sides. So it's a polynomial that contains 3 different or unlike terms. So 5a squared plus 3a minus 7, that's 3 different terms. 4x squared plus 5x minus 8, that is 3 different terms. And then if we have something that's more than 3, it's just called a something polynomial, an n term, and n is the number of terms that it has. So for example, we have 5x cubed plus 3x squared minus 15 plus 2x minus 5y. We have to check if they're all different terms, and we can see that they are. So you would call this a 5-term polynomial because there's 5 different terms. Just call it a 5-term polynomial. Or you can simply just call it a polynomial. But on a assessment, I would want you to write the number of terms that it has, so you'd have to write a 5-term polynomial. But later on, it's not going to matter what you call it. I think there's one more page that we got to do, and then you guys can do the practice work. Yeah, there's one more page. I'm going to circle the homework stuff that I want you to do. And last but not least, so we learned that a polynomial is an algebraic expression that contains one or more terms separated by addition and subtraction. Can someone come up with an algebraic expression for me that has at least 4 terms? Kareem.
5x plus 3 minus 2.
2 what?
2y.
Okay. And you're missing one more term.
And you have a fraction, right?
Yeah.
Plus 3y.
That's still a constant. You have 2 constants. Someone give me a different one. So far we got 5x plus 3 minus 2y, and then we're missing one more term. Someone give me one more different term.
1 over 4.
Pardon?
1 over 4.
No, 1 over 4 and 3 are known as constants, so they're the same. Gian, that's fine. 3y squared. Okay. So now we need to figure out if there's any way to evaluate this expression. There is a way. I just have to assign x and y a specific value. So can someone tell me what they want x to be? What number? Matthew.
5.9.
Oh my gosh, really? Can you give me a-
Really?
Sure, 5.9.
Matthew, you want x to be 5.9.
What's my y going to be? Someone give me a number. Joey?
6.
6, we'll do 6. Perfect. So that means, because Matthew loves his decimals, wherever I see an x, I now have to plug in the number 5.9. And wherever I see my letter y or my variable y, I got to plug in the number 6. So I have 5. Again, this is x. So we said x is 5.9. Plus 3 minus 2. And what did I say y was? It was 6. Thank you, Ethan. Plus 3 times 6 squared. I'm color coding it because it might be easier for some of you to visualize. So, bad math. Let's start with our exponent. What's 6 to the power of 2? Yep. All right. And now let's do all of our brackets. Can someone tell me what 5 times 5.9 gives me? Ethan,
29.5.
is that true?
Yeah.
Okay. What's 2 times 6? Yep, so it's going to be minus 12. And last but not least was 3 times 36. Gian? 108. So now when we add those 4 numbers together, what do we get as our solution? Use your calculators. Some of you are just using your head for no reason right now. Maya?
128.
Yeah.
It is.
So when we evaluate this expression, I get a value of 128.5. Okay. So now you guys are going to do your work. Like I said, I'd rather print the lesson